Good morning, majors. Today we're going to go over Unit 8, Day 3 notes. So we're going to go over the properties proving that we have a parallelogram. So first of all, we're going to talk about a square. You can actually look at the notes before to fill in all of the properties of a square, rectangle, and rhombus. We've already gone over those. So first we're going to look at the sides. For the sides, we're going to have two properties for sides, and then we're going to have two properties for angles, and then we're going to have a property for diagonals for each. Okay, so that's going to put side, side, angle, angle, diagonal. So we know squares are the ones that all sides are congruent. That is true in a square and a rhombus. All my sides are congruent. So this side is congruent to this side, and this side is all four congruent. In a rectangle, that's not true. Only my opposite sides are congruent. So opposite sides are congruent. Of course, that's true in a square and a rhombus. If all of them are congruent, then definitely the opposite ones are. But in a rectangle, this is also true. So this one is congruent to this one, and these are congruent also. Opposite sides are parallel. This is true in all parallelograms, and these are types of parallelograms. So opposite sides being parallel is going to be true in a square, in a rectangle, and a rhombus. So far we have opposite sides are congruent in all three, opposite sides are parallel in all three. All corners are 90 degrees. That is only true in a square. These are 90 degrees, all of them, all squares, always, and a rectangle. So we're going to say this is true in a square, in a rectangle. That is not true in a rhombus. So these two are definitely smaller than 90, and these two are definitely bigger than 90. Opposite angles are congruent. Opposite angles are congruent in all of them. So my opposite angles are going to be something like this. These are not next to each other. These are opposite angles. So these two are congruent. This, even in a rhombus, this angle is going to be congruent to this angle. So it is true in everything. And that's why we put A there for the angles. Consecutive angles are supplementary. That means that they add up to equal 180, and that is true in all of them. Consecutive means the ones right next to each other. So 90 and 90 is 180, 90 and 90 is 180. 90 and 90 is 180, 90 and 90 is 180. But also in a rhombus, whatever this is, if you add it to the bigger angle, they're going to equal 180. So it's true in all parallelograms. The diagonals are perpendicular. This is only true in a square, which means they meet at a 90-degree angle in a square, and in a rhombus. That's true in a rhombus. These meet at a 90-degree angle. So they make right triangles. The diagonals, something that happens in all three, diagonals bisect each other. This is true in all of them. That's why we put the property of diagonals right here, D for diagonals. Okay, so bisecting each other means that this part of the diagonal is equal to this part of the diagonal, and this part of the diagonal is equal to this part of the diagonal because they're bisected. They cut each other in half equally. So this one is equal to this one, and this one is equal to this one. Diagonals are congruent to each other only in a square and a rectangle. It is not true in a rhombus. You can kind of tell that this diagonal is a lot longer than this short diagonal. And then diagonals bisect the angles. This is only true in a square and a rhombus. The diagonals bisect the angles. So what that means is this angle right here, half, is equal to the other half over here. Bisecting means cut it in half equally. This angle right here is equal to this angle right here. But it's not true in a rectangle. You can kind of tell that this bottom angle is bigger than this top angle. But it's true in a square. They're all 45 degrees. Okay. So we're going to go over what a parallelogram is. So go ahead and draw your picture of a parallelogram. Parallelograms must have the following 5 side, side, angle, angle, diagonal properties that we just went over. So everything that they all have in common. Side, side, angle, angle, diagonal. So for my sides, I know my opposite sides, sides and side. My opposite sides are congruent. Maybe not all of them, not always, but my opposite ones are always congruent. So this side is always equal to this side, and this side is going to be equal to this side. My opposite sides are also parallel in all of them. Okay, which means that my slope is equal, and I'm just going to do the symbol for parallel, which is 2 lines up and down. Now let's talk about the angles. In all parallelograms, my opposite angles, AA, my opposite angles are congruent. So this whole angle, this big one, is equal to this whole angle always, and this whole angle is equal to this whole angle. So I'm going to put 2 on these because they're not all necessarily congruent, except in a square. But we're going to have opposite angles are congruent. And that symbol is a congruent symbol, equal. The measures are equal. And also the consecutive, so the ones right next to each other, are supplementary. So right in there, supplementary. Which means they add up to equal 180. Now the diagonals, the only thing that all parallelograms have to have is that the diagonals bisect each other. Let me just change the color. Oops. The diagonals bisect each other. So this one is always equal to this part, and this one is equal to this part. Okay? Now go ahead and flip your paper over. It says that it is a parallelogram. FGHJ is a parallelogram. What is the length of JH? So what is this length right here? But if this side, FG, is 5, then this side has to also be 5. They are equal always. Now, what is the length of J to K? This one is a little bit more tricky, so let's figure this out. But if this right here, K to G is 3, then J to K is also 3 because it's bisected. Okay? So it says this is a parallelogram. What is the measure of angle R? But if P is 140, R is equal also to 140 because they are opposites, right? 140. PQR. So we need to remember how to name an angle or identify an angle. PQ R. So if the top part is 30, how do we find out what the bottom part is? So we know that if these are parallel lines, right? I know that if this is 30, this one down here is 30. But also we know that these angles are supplementary. The ones next to each other are supplementary. So 30, we don't know what this is. We'll say X. So 30 plus X plus this one is 140. They're consecutive. They're next to each other. So plus 140 has to equal 180. They're supplementary. So 30 and 40 is 170. Subtract 170. You'll get X has to be 10. 10 degrees. So you can find SQR is 110. Wait, SQR, this is X, this one is just 10. PQR, they're asking us for the whole thing. So if this is 10 and this is 30, then this one is actually 40. So try to find this. I kind of already plugged it in for you, but try to find it. So it says this is a parallelogram. What we know is that these two angles that are next to each other have to add up to equal 180. So add them up and set them equal to 180 and try to find out what X is. I'm going to help you guys make a Venn diagram, and then you can fill out this information. If we have a Venn diagram, our universe is called quadrilaterals, which means 4-sided figures. And in quadrilaterals, we have a box that's going to be called parallelograms. So put a big box. We're going to have other things in it later other than parallelograms, but in this case, all we've learned so far are parallelograms. And we have types of parallelograms. Okay, so we can maybe, we have 2 different types, and then, well, 3 different things that we've learned so far. So we have rectangles right here, right, rectangles. And we have a rhombus. Multiple rhombus is called rhombi. So this is going to be a rhombi right here. Rhombi. And so this is going to be properties of rectangles, properties of rhombi, and where they overlap is going to be a square. A square. So the square goes in the middle. All right, guys. So I want you to use this information and try to identify the definitions. You're going to just tell me if they're true or false. A rectangle is a type of parallelogram. The rectangles are inside the parallelogram, so this is true. Let's try number G. A parallelogram is a type of rectangle. So is a parallelogram inside the rectangles? No. So G is false. Use your Venn diagram that I helped you make. Determine the most precise name for the quadrilateral. So we know it's a quadrilateral. We can say that they're a parallelogram, but do we have something more specific? Do we know that it could be a rectangle, square, or rhombus? We know our opposite sides are equal, but not all four, so it's not a square. We have 90-degree angles, so I know that this is a rectangle. Try the rest. So this is just going through what we had just done on the other paper, so just fill in the information again, and then we're just going to do some examples. Okay, so try these out and we'll go over some of them in class tomorrow. Have a great night.